Water treatment and delivery on the Canadian prairies has undergone profound transformation over the centuries. First Nations peoples had developed deep knowledge and sustainable practices for accessing clean water, sourcing water from springs, rivers, and lakes, and carefully selecting locations with natural filtration systems like sand beds or gravel, and using techniques such as boiling and charcoal purification. Practices grounded in an understanding of the land and a spiritual connection to water as a sacred, life-sustaining force. With the arrival of settlers in the 19th century, prairie communities began to build rudimentary water systems, often relying on wells, cisterns, and direct river access. As towns and cities grew, the need for organized municipal water systems became evident, particularly in Winnipeg. In Manitoba, the Shoal Lake Aqueduct, completed in 1919, became a major infrastructure achievement, supplying Winnipeg with clean drinking water from Shoal Lake located on the Manitoba-Ontario border. While this solved the water needs for the urban population, it had severe consequences for the local First Nations, including the isolation of Shoal Lake 40 First Nation, which would not gain permanent road access until a century later. Throughout the 20th century, water treatment technologies evolved to include chlorination, filtration, and a host of other advanced chemical, mechanical, and biological processes. However, infrastructure gaps persisted in rural and Indigenous communities, many of which continue to face long-term boil water advisories to this day. As this podcast is being recorded, we're marking the 25-year anniversary of the public health tragedy in Walkerton, Ontario, in which 7 people died and thousands fell ill due to E. coli contamination in the municipal water supply. That event marked a turning point in Canadian water governance and prompted sweeping regulatory reforms across the country, including stricter water quality monitoring, operator training requirements, and public transparency measures. One of the clearest lessons learned is that water safety cannot be taken for granted. It requires constant vigilance, investment, and accountability. In Manitoba and across the prairies, efforts have increased to modernize infrastructure, integrate Indigenous voices into water governance, and recognize that equitable access to clean water is both a public health necessity and a human right. Our trust in water systems is built not only on technology, but on stewardship, respect, and justice. Working in that world is today's guest on the AE Live podcast, Ken Anderson.
Coming to you on the internet, audio, on my stem, homies know AE's where you gotta go. Shuffle to the rhythm of the Grandma Michael groove. It's a whole new pure plur interview. Treat your ears to the gist of careers from the list of our engineers and scientists, maybe twisted up with technologists. It's a podcast, baby, and not to be missed. Got more fly than a ripe banana, like the salmon got the stamina streaming across Canada. Like a trade show cabana, got that swiggity swag and the 411 for my horse Niagara. AE Live, don't you know we're gonna innovate? AE Live, got a topic here to elevate. AE Live, here to entertain and educate. AE Live, oh! AE Live, don't you know we're gonna innovate? AE Live, got a topic here to elevate. AE Live, we're gonna entertain and educate. AE Live, oh!
I'm Michael Tolboom, Associated's creative leader, and I'll be your host on today's episode of AE Live. To talk more about water and the challenges of smart planning for water infrastructure on the Canadian prairies, I'm joined by Ken Anderson. Ken is our manager, water, in Associated's Winnipeg office. Thanks for joining me today, Ken, and welcome to the podcast.
Well, thanks for having me.
Ken, you have a Bachelor of Science in Civil Engineering degree from the University of Manitoba. Got that back in the 90s, 1996. 27 years into your career now, you're in a fairly senior position with us. Tell me about some of the key moments that brought you to this point.
Okay, generally, it came down to 2 key moments, decisions that I made in my career to get to this point. After graduating and about 1997, I started working for a developer that helping project manage and construction of new commercial and industrial warehouses. I was doing that for a few years, but because I wasn't working under an engineers at the time, I was not really furthering my career at a certain point I decided it was a change. Although I was gaining valuable construction and project management experiences, I wasn't really working towards my PEng. So after 2 years there, in about 1999, I decided to quit and focus on finding a job in engineering in my field that I studied so hard for. In just a few months, through a series of contacts, the old adage there, it's knowing somebody who knows somebody, or it's who you know, not what you know, I ended up landing a job at Cochrane Engineering as a junior engineer. And lo and behold, my boss at that time is just Jeff O'Driscoll. And 25 years later here, he still continues to be a pretty good boss. So that was decision number one. And decision number two that came after about 12 years of working with Cochrane, eventually became Genevar. I felt again that I needed a change. I told Jeff that I was thinking of leaving. And our next employee performance review was us discussing where we're going to go work next.
Going together.
Yes. It was, we were a package deal. There was a few of us that had a pact, I guess. So after a few months and a whole other good story there, Jeff and I, along with Desiree, who's still here, opened the Associate Engineering office in June of 2011. And 13 years later, we're still going strong, still very happy to be here, and they only wished they had gotten here sooner.
Does the other good story involve like a stolen car and a flight to Tijuana or anything like that?
No, it was just meeting up with Rod and Bert Monroe at the time, and just the discussions going back and forth where, do you want to open an office? Yes, we want to open an office. So we sort of came to a pretty good congruence of interest there. We sort of noticed that AE had an office in the 50s, closed down many, many years ago, almost before I was born. And here we are opening it again. So that was pretty interesting.
I think that's interesting that, like you were saying, you started in civil engineering and doing kind of buildings engineering.
Yep.
And like now you're doing something very different. And, we talk to young engineers just starting their career, and it seems like they're often just kind of feeling out what strikes them as interesting in the field, right?
Yeah, it was a pretty good change. But at that time in the 90s, work was hard. You sort of got what you got to get experience. And it really became a step up, just to at least get some experience in the construction in the industry to be attractive enough to the employer that I finally got hired on.
Right. But now you're doing water.
Yes.
Primarily. So tell me a little bit about, I guess, when you realized water was going to be the focus of your career. Did you have any inkling about that?
No idea. I was just happy to have a job at the time. But when I was hired at Cochrane, being the junior engineer, but because I had some construction background for a few years of experience, I was designated to be the resident engineer for about 6 months on a new water plant in rural Manitoba. And then soon after that stint, I was once again placed as the resident engineer for another water plant upgrade in the city of Prairies, and that was about just over a 1 year stint. So being around those plants, being around the construction and the design aspect of all this, I was just hooked on water after that. So it was just, the story was already made.
So can you give our listeners kind of a quick primer on what, I guess, those jobs entail and what we can offer a client now? What kinds of work that you're doing these days?
Sure. Yeah. In general, our group here plays a role of like the trusted advisor to many, many of our clients and communities. So although we focus on water and wastewater infrastructure, we also tend to provide the full meal deal, whatever our clients need. They give us a call, be it a structural specialty, environmental work, waste disposal grounds. I find the team and we deliver the project to them. But for myself, I specialize in water treatment plants. Not the smelly kind. But I can either be from micro packages that are in our CMP stations or campgrounds, all the way up to our medium-sized municipalities where they're 13 megaliters a day, not city-sized, but a good size.
Can you give our listeners a bit of, I guess, sense of scale on this? Like you're talking a micro package, is that like a system that's sufficient, like for one building? Or
yeah, Mike, like remote RCMP detachments will be self-sufficient. So or even border stations. So we get in there and find the source, groundwater, surface water, and like you said, usually it's for a half a dozen people. So these are small little package plants we put together with an architect and develop either as a standalone water plant facility or incorporated into the plant structure itself. And they run 1 liter a second, 1-2, so like not very large. And the idea there is to keep it as simple as possible, because half the time you have the RCB guys wanting to or having to manage these facilities or operate them or change the chemical, and they're not really inclined for that kind of work. So you got to make it as easy as possible on them.
Where would the water from those be coming from? Like, are they pulling out of a local well or a river?
Most times they're actually out of a nearby lake. We're in the north when we do these projects, so we'll have our a pretty good source nearby that's there, but it does have its own challenges. In the north here in Manitoba, we have high colored water, but it's soft, so the treatment is really just getting the color out and making it safe with disinfection.
Is there a worry with that, like with Giardia or Salmonella?
Well, that's the steps. Our challenge is to treat for those, but trying to keep it simple. So we'll have multiple sand filters, pretty much residential grade type of filters, so they're easy to operate, easy to maintain, followed by a layer of cartridge filtration. Again, very simple. Change the filter out as needed, and then some ion exchange to remove the color so that our UV reactors can work. So getting a little technical here, but it's a challenge, that balance, like you said, making the water safe, but also keeping it simple to operate.
And then the next stage up, I think you said 12 megaliters a day. That's something like what Portage la Prairie would have put in?
The Portage would have been probably about 2 to 3 times that size as a large city. In Manitoba, we pretty much step quickly down after you get from Winnipeg through Brandon and then Portage. And then we have our 10,000 person communities. And that's really where our sweet spot lies. Once you start getting into those 3rd, 4th, 5th largest communities in Manitoba, that's sort of where we live in terms of working for those clients.
I was going to ask you to speak about a couple of example projects. I know you and I had talked earlier. Is there anything in particular that's interesting these days that you want to tell us about?
Yeah, I picked a couple examples of some projects we're working on that we're pretty excited or pretty cool that I find. That's not the sort of run-of-the-mill groundwater, reverse osmosis, you're done kind of idea. So we have one project we're working on where we're working for a community that had some pretty stringent water restrictions. They had a very limited supply of raw water. They also have certain limitations on discharge. So they have a future plan of eventually being a zero liquid discharge facility, which means no waste product leaving it in terms of process waste from a treatment process, which is not typical in Manitoba, maybe more in the south, in the California, Nevada areas, but here, not that common. But they were in a unique situation that they were aiming towards that objective. So they had a challenging source as well, very brackish source water, groundwater.
So that means salty. Right?
Very salty, yeah. We're tapping into like hundreds of feet down into the aquifer that was from the old Lake Agassiz that used to be above us like 10,000 years ago. So pretty old water that's had a long time to sit and pick up the minerals in the stones. So it's not easy to treat. The water coming out of the ground is literally doesn't meet the regulations for discharge back to the surface. So that's one of our challenges. It's so much chlorides and sodium that it exceeds discharge limits to the local rivers and streams. So part of the zero liquid discharge is to eliminate that concern. Even if we pull it out, blend it with wastewater, it's still too high to be discharging eventually. So they want to take it out of the system by a zero liquid discharge. We'll crystallize it, evaporate it, bring out the solids as opposed to releasing it to the environment.
What does that mean to crystallize it?
Certain technologies you can use on the treatment process will evaporate you pull the H2O out of your waste and you left with the minerals and the concentrates as a solid.
Just like distilling alcohol.
Yeah, I guess. Yeah, you're removing the liquid part and concentrating it. To this point, we're concentrating it into a pure solid, so it can be disposed of separately as opposed to or beneficial reuse of some form. So the challenge with that is we have to minimize our waste stream. So this technology we chose for treating it, working with the client, is a more advanced form of reverse osmosis, where a normal reverse osmosis would recover about 75% of the flows. So 75% of the water you treat goes to the treated source, and 25% is considered waste product as the concentrate. This new technology we're looking at, sort of new technology we're applying in the province here at least, is There's a higher recovery up to 92%. And as you get past about 80% recovery, things get exponentially more difficult and costly. So this technology is probably about 4 times more costly than a normal RO system, but the community was pretty adamant of their objectives and were willing to take those steps. It also means, with the idea here of the higher recovery, means less waste. And less waste in the future means less costs to handle it and further dewater it and crystallize it. So that was the objective of this first phase of work. Then construction is just starting, and it should be complete next year. So we'll see how this works out. The other project I'm pretty excited about is we're upgrading another plant for a nearby community here. But this was a plant I upgraded in 2010, just before joining AE. It was my last plant upgrade. And we're back again. We're not only doubling the plant capacity because of their pretty successful growth rates in the community in their areas, but we're also working on a technology change for the membranes. So in 2010, that was one of the earlier plants that we had converted from our conventional lime softening plants in Manitoba to a dual membrane system, converting from just conventional treatment that we had probably about dozens of these plants in Manitoba, and we felt that membranes were a more effective and efficient treatment technology, and new, so it's not. But over 12 years of operations, there's been some lessons learned. But now that we're back there, we're actively collaborating with the operators and dialing in the design and the plant features that will hopefully make their lives a bit easier on them going forward.
With the lessons learned, is that the water that they were dealing with, that membranes just couldn't deal with the specific properties of that water?
Yeah, there were certain challenges with membranes that popped up over the years. You run the plant harder, the membranes were a shorter life than we expected, was more of the largest surprise that you couldn't foresee. Even though we show that they work well, but after 12 years of operation, you realize that you maybe think you get 10 to 15 years out of a membrane, you get 5 if you're lucky.
But they're super cheap to replace, right?
Right. Nothing's cheap these days. But it's also a hassle to replace the membranes. Not only expensive when you're spending maybe close to $500,000 every 5 years replacing your membranes. If we can extend that replacement period through a little bit more engineering and capital up front, it was worthwhile for the clients. So we're using membranes still, but a different style that should alleviate that longer life out of them. But again, what I think is neat about this project is we continue to be their trusted advisor. We continue, after 12 years later, even under a different company, we're still their go-to team for designing this plant and upgrading the plant. So we're pretty happy with that.
We here at AE talk a lot about managing climate change, bringing that to our clients. How does that affect the work that you do and the planning process that you present to clients? What kind of response do you get these days when speaking to climate change mitigation and adaptation in a client project?
Well, we're in water here, so the impacts are pretty apparent to our clients. It's pretty direct. So we've seen some impacts of drought recently here with the low river water levels, and coming in spring with not enough precipitation in the south, what accumulates our system. So we've actually seen some pretty short-term impacts of it, and our clients have experienced it as well. So
I gotta say, when I think of low water levels, I don't think of Winnipeg.
No. But when you can almost walk across the Red River, that's normally 20 feet deep during the spring as opposed to 2 or 3 feet deep, it's a pretty big change. Yeah. So at that time, we were pretty actively helping some clients draft some emergency measures to mitigate these if this drought continues, or if this was to reoccur again. Temporary ponds or permanent ponds, seeing if there was options to dam up rivers, get prepared for this. So we were starting to develop some of these actions, and they realized the importance of those. So it was just firsthand realization that this could become a normal as opposed to the outlier. So it's a big topic, yes. Common conversations we're starting to have with our clients is, sure, we can expand your plant capacity, but will you have enough water in that river or that lake or that stream that you're pulling from right now to meet your increased demands? And they realize that it's a tough conversation. But it's not only easy, but it isn't cheap.
Yeah. Well, you're expanding like the whole scope into a whole water resources conversation.
Exactly. Not just a plant, it's other infrastructure that may be needed to ensure the sustainability of that water supply. Either pulling it from other sources, large storage ponds, it can drastically impact the project budget if they have to start considering this lack of water come the future.
Yeah.
But they're very receptive to the discussion. They're not ignoring it. They realize it. But it's still a tough decision to say, yeah, we should do that, but where are we going to find the money to do that? So they phase it in. Usually it's the typical reaction is to kick it down the road, but until the next emergency comes. We went from those years of drought where we had low water levels to the following year where we had too much water. We started having some flooding events. So their focus quickly shifted and the attention on drought got put to the side, and until the next one comes along, that's when the attention gets focused back on it. But we're trying to train them to start thinking about this before it happens, not when it's happening. And they appreciate it. They realize that. But it's always the question of where am I going to find the funding and where am I going to find the money to do this?
Do you find that the quality of the water that goes into our systems here is affected by climate changes? I know Winnipeg is probably getting its water from places that originate south of the border.
Yeah, a lot of the plants that we are working on currently get their source from the Red River, the Assiniboine River, so it's coming from out of province. The smaller plants are mostly groundwater around here, so not as affected. But we do see lowering groundwater levels, so we have to consider the effects not only of our wells that we're putting in for these plants, but how they might affect the surrounding population wells. Sometimes the water goes down and they blame the community for taking their water when it really is just a lowering of the water level due to lack of recharge.
Right.
So an indirect climate change that becomes again another discussion with the clients to say it's not really you, but you still will be responsible for making that right for your residents. In terms of flooding, we've seen some communities where we have too much water in the spring, and you see the lake water quality gets pretty horrible from that amount of runoff, and treatment is pretty challenging. So in some of those places, we have to get in there and help them improve their treatment or come up with different strategies to deal with those events that happen again. They could be happening more regularly as opposed to once every 10, 15 years.
Yeah, I imagine you'd see quite a drastic change in turbidity with over the course of a couple of weeks.
Yeah, a few years ago, we had a project in the community where that event was causing upsets in their treatment process, which caused them to go on boil water advisories. And part of our solution for them to get by was to install new UV reactors as a redundant treatment process. So the UV will allow them to stave off a boil water advisory if the reactors are demonstrating efficient disinfection, even though their conventional treatment might be a little bit high on turbidity numbers. So it's that redundancy in their treatment that they needed for the regulator.
I ask this in all my interviews. In my own field as a graphic designer, we have the saying that good design is invisible. In your field, are there successes or accomplishments that you feel like they're getting unappreciated, going by unappreciated?
I guess it's a pretty answer. It's a pretty answer in my type of work. We build water plants and wastewater infrastructure. So when people turn on the tap or flush a toilet, I don't think they're thanking me or us when they do that. But we're not in this really for the accolades from themselves there. We sort of understand it's expected to have that safe and secure source there. What makes this job rewarding for my team and myself is that the feeling appreciation from our clients on making their lives easier and delivering successful results. Them providing us sole source work, being the trusted advisor, relying on us, shows us our appreciation, I believe. Not just the work that we do.
Just with an eye to the future, as we wrap up the interview here, what do you see as the biggest challenge or threat on the horizon, or maybe opportunity? Is there something coming down the pipe that's exciting?
Exciting? No, I don't think that's the word for it. I think it's more scary. When I thought of this question, what pops in my head was we're preparing the clients a lot these days more for budgets and costs of their construction right now. We're always getting shocked at our tender prices, where we get funding years ago, we execute the project, deliver it, tender it, and it comes in significantly above the available funding that they had put in place years earlier. Just the inflation rates and the cost of construction is climbing faster than historical that we've seen. So most of my discussions, like you're saying, of what we're talking to our clients and warning our clients, is that cost escalation is something we have to consider. So basically, we're trying to educate them that their dollar probably won't go as far these days as it used to. So in my plants that we're designing, we say, let's make a priority list. Like, there's a wish list, there's a want list, and a need list. And if you sort of install all the wants and the wishes of these operators in the system, you end up with a great plant, but it's just way above their pay scale. Like, they just can't afford that type of plant these days. So in the past, they probably could have had these features in it. So we try not to blow their budgets out of the water by giving them all the wish items. So there's a bunch of the conversations that we have and challenge them to say, do you really need this now? Can you defer it? Or let's just focus on the core of this project to be able to fit it into your budget. And that seems to be more of my conversations these days.
Right.
And managing their expectations.
What kind of things do you find are kind of dropping off the features list in the plants that are getting developed now?
Some of our current plants are the operators wish they can upgrade some of their older systems. We get in the plant, we're expanding it, we're adding a new building addition, new systems, new HVAC, electrical. Then they go back and look, well, my 20-year-old stuff here is falling apart. Can I fix that too? So we've sort of in past have been able to incorporate a bit of replacing HVAC, replacing electrical systems as part of the scope of the project. But we're just seeing just how tight things can be, that is a wish list now. Like, we can allow for it if we have enough funding at the end of the project to do that, but we don't want to incorporate it into our jobs right now and end up over budget and having to delete it. And we know construction that if we try to delete something after the fact, it's a lot. We don't really get the full credit for it. So if you put it in there, it's already overpriced to begin with. And then when you try to take it out, it's just, they're still paying for it. So we try to manage them and say, let's handle that in a different aspect as opposed to putting it all into our initial tendering project.
Right. Well, before I let you go, because this is a podcast and, we have to follow the international rules of podcasting. Can you tell me what your favorite cocktail recipe is?
Oh, some form of old fashioned. That's not much of a recipe as long as the ice is right and if they can smoke it. But there's not much else you add to that.
No? Do you have one of those fancy smoker things?
No, not myself. That's something I enjoy when I go out. I don't think I'd be allowed to have that in the house.
All right. Well, thank you so much for joining me today, Ken.
No, thank you.
Wish you all the best in your upcoming projects.
Okay. No, thanks again.